Hello students, today is our second class on this chapter binomial theorem and we are right now dealing with only positive integer powers. And in our last session we have seen that in CR you can write this in this form or in this form or in this form. And they represent the binomial coefficients. And we have found the values of NCR for different values of N and R using the TI-NSPAR calculator in our last session. And in our today's session, we'll be finding these values manually because for IBDPA students, you have the paper 1 in which calculator is not allowed. So you have to know how to find these values manually. So this NCR or NCR written in this form or in this form, these are equal to this formula. But how do you read them? In exclamation mark and then not at all a familiar thing. How do we read this? Read n factorial, this is n exclamation mark as n factorial. So now NCR is equal to n factorial over r factorial times there is the implied multiplication sign in between n minus r factorial. And what is n factorial or r factorial? What are these? N factorial is n times n minus 1 times n minus 2. It just goes on decreasing in steps of 1 up to the point when it reaches 1. It stops when it comes to 1. And 0 factorial, the value of 0 factorial is 1. Like if you have to get the value of 1 factorial, you start with n factorial means n is equal to 1. You start with the value of n and you stop when you reach 1. But over here n is equal to 1, so you stop over here. Therefore, 1 factorial is equal to 1. When n is equal to 2, that is 2 factorial, you start with the n value as 2. And then you go on decreasing the value of n by 1 until you reach 1. And the numbers will get multiplied. So 2 times 2 minus 1 is 1 and we stop. 2 times 1 is 2. So 2 factorial is equal to 2. What about 3 factorial? N is equal to 3. So we start with the n value. It will be 3 times n minus 1. 3 minus 1 is 2. N minus 2. 3 minus 2 is 1. And we stop as soon as we reach 1 because this is the last factor. So it is 3 times 2 times 1 are equal to 6. 3 factorial is equal to 6. 4 factorial. We start with 4 and we go on decreasing the value in steps of 1 till we reach 1. So it is 4 times 3 times 2 times 1. 4 times 3 is 12. 12 times 2 is 24. So 4 factorial is 24. 5 factorial. 5 times 4 times 3 times 2 times 1. 4 factorial, we know this part, we know it is 24. 24 times 5 is 120 or 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. Okay. So now we see one relation. What is the relation? The relation is, suppose we are taking 3 factorial. This part is the 2 factorial. This part is the 2 factorial. Okay. This part, it was 2 times 1 which is equal to 2 factorial. So, we get 3 factorial equal to 3 times 2 factorial. What about 4 factorial? 4 factorial is, it is, let me take some. If we take this part, this part was 3 times 2 times 1. which is 3 factorial. So 4 factorial is 4 times 3 factorial. What about 5 factorial? 5 factorial will be 5 times 4 factorial. So it can be taken as, say, this one. This part is 4 times 3 times 2 times 1, which is 4 factorial. So 5 factorial is 5 times 4 factorial. This is what is written over here. N factorial is n times n minus 1 factorial. This is important. Okay, you have to remember this. N factorial equal to n times n minus 1 factorial. Okay, now we know how to find the value of a factorial, and we know the relation between n factorial and its immediate previous numbers factorial, that is n minus 1 factorial. Okay, so now let us come to this part where we are asked to find some values of NCR. See over here, it is 4C0. That means n is equal to 4, and r is equal to 0. So n equal to 4 over here, r equal to 0. We will be just substituting. The numerator is n factorial, so we will be writing 4 factorial over r factorial, r is 0. 0 factorial times n minus r, that is 4 minus 0. 4 minus 0 factorial. Okay. And 0 factorial, we know that to be equal to 1. So this is, and 4 minus 0 is 4. So this is 4 factorial over 4 factorial, which is equal to 1, because we have seen this is 4 factorial. This one is, okay, the numbers are not getting seen. They are no more visible because these are actually the pictures. That is why when I'm highlighting them, it is no more remaining visible. So this is 3 factorial and this is 4 factorial. And 4 factorial is 24. So it is basically 24 divided by 24, which has to be equal to 1. Coming to 6C0, where n is equal to 6 and r is equal to 0. The numerator is n factorial, so it will be 6 factorial over r factorial, that is 0 factorial, times 6 minus 0 factorial. And 0 factorial is 1 and 6 minus 0 is 6. So it is 6 factorial over 6 factorial. Doesn't matter what is the value of 6 factorial. The numerator value and the denominator value, they are the same. So the final answer will be equal to 1. Okay. Coming to the next one. 20C0. 20C0. N equal to 20. So 20 factorial in the numerator. Denominator r factorial, that is 0 factorial. And 20 minus 0 factorial. So again it is 20 factorial over 20 factorial, which is equal to 1. So you see, doesn't matter what is the value of n. The n values are different, but the r value is the same, it is equal to 0. And we are seeing that whenever the r value is 0, it doesn't matter what is the value of n, the factorial value is equal to 1. Clear? Okay. So we come to the next part. Let us go to directly to this part, and let us do this. 1C1. Over here n is equal to 1 and r is also equal to 1. 5C5. So the r value and the n value, they are the same. Okay. So, but the relation is the same. Doesn't matter whether the n and r, they are having the same value or not. The formula remains the same. Since it is no more visible, I am writing it once more. N minus r factorial. Okay. NCR equal to n factorial over r factorial times n minus r factorial. So it is 1C1, that means n is equal to 1 and r is equal to 1. So the numerator is 1 factorial, which is of course equal to 1, over r factorial, that is 1 factorial, and n minus 1, that is 1 minus 1 factorial. Okay. 1 minus 1 factorial is 0 factorial, which is equal to 1. 1 factorial is 1, so it is 1 over 1, which is equal to 1. Clear? Next is 5C5. So n is equal to 5, r equal to 5. Therefore, the numerator is 5 factorial. Denominator is r factorial, that is 5 factorial, times 5 minus 5 factorial, which is equal to 5 minus 5 factorial is equal to 0 factorial, which is 1, and 5 factorial divided by 5 factorial is 1. Similarly, for 32C32, it is 32 factorial over 32 factorial and 32 minus 32 factorial, which is again equal to 1, because 32 minus 32 is 0, 0 factorial is 1, and 32 factorial over 32 factorial is 1. So now you notice, doesn't matter what is the value of n. N value is different in these three cases, but what is special for these three is that the n value is equal to the r value. Whenever the n value is equal to the r value, the NCR value is equal to 1. Or we can say NCN, because r is equal to n. So NCN is equal to 1. And when the r value is equal to 0, that means NC0 is also equal to 1. These two we have found. So this is the relation NC0 equal to NCN equal to 1. So this is the thing that we have seen in the Pascal's triangle also, that each row in the Pascal's triangle starts with 1 and ends with 1, because NC0 is the coefficient of the first term of the binomial expansion and NCN is the last term's coefficient in the binomial expansion. So both are equal to 1, and using this formula also we have verified that they are indeed equal to 1. Okay. Now coming to the middle two columns, rather. So for this, n is equal to 3 and r is equal to 1. N is equal to 3 and r is equal to 1. So the formula n factorial over r factorial times n minus r factorial. So it is 3 factorial over 1 factorial times 3 minus 1 factorial, which is 3 factorial over which is 3 factorial over 1 factorial is 1 and 3 minus 1 is 2. 2 factorial. But we know this relation. N factorial is equal to n times n minus 1 factorial. So in place of n, if we write 3, it will be 3 factorial equal to 3 times 3 minus 1, which is 2 factorial. So that is what we will be writing. So this is 3 times 2 factorial over 2 factorial. So this is equal to 3. Okay. So 3C1 is equal to 3. For 7C1, what happens? N is 7, so it is 7 factorial over 1 factorial and 7 minus 1 factorial. 7 minus 1 is 6. So we will be writing 7 factorial as 7 times 6 factorial. Using this formula. Again, that is why I have said this is very important. 7 times 6 factorial over 6 factorial. So these two will be getting cancelled. Even these two got cancelled. And the answer is 7. Okay. For 10C1, again, 10 factorial over 1 factorial and 10 minus 1 factorial. It is 10 minus 1 is 9, so we will be expressing 10 factorial in this form. 10 times 9 factorial, because we are having the 9 factorial in the denominator, so that these two can get cancelled and the answer will be equal to 10. So you see, n values are different, but the r value, they are the same, and the r value is equal to 1. So doesn't matter what is the value of n, NC1 is always equal to n. When n is equal to 3, the value is 3. When n is equal to 7, the value is 7. When n equal to 10, the value is 10. So, and this is the coefficient of the very first term. It is 1, you have seen. This is the coefficient of the last term. You have seen that to be 1 as well. But what will be the second term's numerical coefficient? If it is a paper one, you will not be allowed to use the calculator. You don't have to calculate. You just write the coefficient as the value of n. You get the second term's numerical coefficient. You simply don't have to calculate anything, because NC1 is equal to n. Okay. So that is the relation that I have written over here. NC1 is equal to n. Now coming to NCn minus 1, means whatever is the value of n, the r value will be just one number less than the n value. C6, C5, n equal to 6 and r is equal to 5. 6 minus 1, that is 5. So what will be the value? N factorial, that is 6 factorial, over r factorial times n minus r factorial, that is 6 minus 5 factorial. And 6 minus 5 is obviously 1 factorial, which is 1. And 6 factorial, again we can write this as 6 times 5 factorial over 5 factorial. These will get cancelled and we will be having 6. Similarly, 12C11, 12 factorial over 11 factorial and 12 minus 11 factorial. So, this can be written as 12 times 11 factorial over 11 factorial, which is equal to 12. And this one, 9C8, 9 factorial over 8 factorial times 9 minus 8 factorial. 9 times 8 factorial, the numerator can be written as 9 times n factorial, 8 factorial over 8 factorial. So the ultimate answer is 9. So this is the case of in Cn minus 1, where the R value is just one number less than the n value. And we are seeing whenever we are having in Cn minus 1 case, the ultimate answer is the value of n. And which term's coefficient is this? It is the second last term's coefficient. And you have seen the symmetry in the Pascal's triangle, you have seen the symmetry. So it has to be this case. The first term's coefficient is equal to the last term's coefficient. The second term's coefficient should be equal to the second last term's coefficient. I am marking 3 over here and 6 over here. They don't match because the n values don't match. Okay. But the second term's coefficient should always be equal to the second last term's coefficient, and that will be equal to n. Clear? So you don't have to calculate the first term's coefficient, the last term's coefficient, the second term's coefficient, the second last term's coefficient. So you see, you are saving time. Okay? Now coming to the binomial expansion. We have done the binomial expansion in our previous session as well, but this is the general form of the binomial expansion with the variables. So a plus b raised to the power of n is equal to, the first term is nc0, first term's coefficient, we have seen that to be equal to nc0. A will be raised to the power of n. Actually, it is raised to the power of n minus 0. Okay, that is equal to n. And b's first power, starting power is 0, that also you know. You see the relation. This is n, and which can be written as n minus 0. So we are just subtracting these two numbers. The higher number minus the lower number. They don't have any hierarchy, but with respect to their positions, and I cannot say that as well. If you write this as nc0, even if you take this as this, then it will be the left term minus the right term. So whatever way you write, it is n minus r actually. Okay. So it is n minus r minus 0, which is giving the power of a as n, and the power of b is simply the value of this lower number. Okay. The second term's numerical coefficient is nc1. You see that the hard thing, n is the same for every term, but this number is changing. Over here you don't have the existence of the letter r, but they represent the r values. In our coming session next Saturday, we will be taking up this r, where the r value, r letter will be visible. Okay, but for this session I did not take the r letter. I have just expanded and I have written the terms just one by one. Okay, but the r value, these numbers represent the r values. Okay, and the r values are different. But for a binomial expansion, this is the n, which is the power. It has to remain the same. The r values go on changing, go on increasing rather. The r value starts with 0 and it goes on increasing in steps of 1. For every term, the r value is 1 more than the previous r value. Okay. So the nc0 A's power is n minus 0, which is n, and B's power is simply the R value, which is 0. This is the thing that we had seen in our previous session also, that the power of A will be going on decreasing and the power of B will go on increasing. So the next term's power of A is n minus 1, then it is n minus 2, then it is n minus 3. The last term's power of A will be 0. And the power of B starts with 0 in the first term and it goes on increasing 0, 1, this is 2, very sorry. This is 2, this is 3, and ultimately it is b to the power of n. Okay? And the numerical coefficients are NC0, NC1, NC2, NC3 up to NCn. And how many terms are there in this expansion? Because the power is n, there will be a total of n plus 1 number of terms. We have seen all these in our previous session. So now we come to the very first question of this chapter. What is the binomial expansion of x plus 2 raised to the power of 4? Okay. If we just relate this with this, we see this is the answer. A is equal to x and B is equal to 2. And what is the value of n? N is equal to 4. So we will be just substituting these values in this expansion. So we write x plus 2 to the power of 4 is equal to, it is NC0, and we have just now seen that NC0 is equal to 1. And in our previous session also we had seen that the starting term's coefficient, the first term's coefficient is always equal to 1. So we are not writing the 1 explicitly. B to the power of 0 is also not written explicitly. The only term which is visible as the first term is e to the power of n, and e is equal to x in our case. So x raised to the power of n, or n equal to 4, that is x raised to the power of 4. Plus, because it is x plus 2, we will be having plus sign connecting all the terms every time. And instead of x plus 2, if you have x minus 2, the only difference will be the signs will be plus minus, the starting term's sign will be plus, and the signs will just go on alternating plus minus and so on. Okay. Second term, in C1, we have just now seen, doesn't matter what is the value of n, when the r value is equal to 1, the NC1 value is equal to n. In this case, the n value is 4. So 4C1 should be equal to 4. Okay. And e to the power of n minus 1. So e is x. X to the power of 4 minus 1, that is 3. And now we have the b. B is equal to 2 times 2 to the power of 1 plus in C2. Now this we do not know, we have to calculate. So in C2 n value is 4. Therefore we write 4 factorial over r is equal to 2. So 2 factorial times 4 minus 2 factorial. Okay. X to the power of a to the power of n minus 2. 4 minus 2 is 2. X to the power of 2 and b to the power of 2. 2 to the power of 2 plus 4C3. This is n is 3, n is 4 and r is 3. 4C3. This is the case of NC n minus 1. So it should be equal to n. We straight away write this as 4. A is x to the power of n minus 3. 4 minus 3 is 1. And b to the power of b is 2 to the power of 3. Plus ncn is 1. A to the power of 0 is 1 and b to the power of n, that is 2 to the power of 4. Okay. So this is equal to x to the power of 4 plus 2 to the power of 1 is 2 times 4 is 8. So you have to multiply it. It's not that you are having, this is a single term and you are having two numerical factors and you keep them as it is. No, they will get multiplied. Okay? The numerical coefficient is 4. But if you have some number in as one of the terms or as a part of one of the terms, then obviously those should also get multiplied with the numerical coefficients. Okay? So 8x cubed. What about this? 4 factorial, let us do this. 4 factorial is 4 times 3 times 2 times 1. 2 factorial is 2 times 1. Again 4 minus 2 is 2 factorial. So it is 2 times 1. So I can just cancel this. Okay. And this is x square times 2 square is 4 plus 2 to the power of 3 is 8. 8 times 4 is 32. 32x plus 2 to the power of 4 is 16. So our final answer will be x to the power of 4 plus 8x to the power of 3. This one is 3 times 2 is 6. 6 times 4 is 24. Plus 24 x to the power of 2 plus 32x plus 16. See, you are having 5 terms. 1, 2, 3, 4, 5. Because the n value is 4. Okay. And the power of the x goes on decreasing. 4, 3, 2, 1 and finally 0. The b, since it is a number, it is not visible. But it is also there because when we had started, it was 2 to the power of 0 for this term, 2 to the power of 1, 2 to the power of 2, 3 and finally 4. Okay. Coming to the next question. What is the binomial expansion of 2x plus 3y raised to the power of 6? Okay, it is, there will be 7 terms. Fine. So let's start. Let me just write it over here, the expansion, because it is no more visible. A plus b to the power of n is equal to nc0 a to the power of n plus, I'm not writing b to the power of 0, nc1 a to the power of n minus 1 b to the power of 1 plus nc2 a to the power of n minus 2 b to the power of 2. It goes on till we come to ncn and b to the power of, there should be a plus sign, b to the power of n. So this is the binomial expansion and there will be 7 terms in this case because n is equal to 6. me draw a line over here. Okay, fine. So answer. Over here, E is equal to 2x, B is equal to 3y. Okay. In our previous session, first session, I had said that you may have multiple variables. It's not that you will be having only a single variable. You can have multiple variables. You can have the same variable with different powers present in the two terms. Okay. You may have multiple variables in a single term as well. So in this case, E is equal to 2x and B equal to 3y and N is equal to 6. So 2x plus 3y to the power of 6 should be equal to, the first term's coefficient is 1, so I'm not writing 1. It is 2x, that is A, to the power of n, which is 6, plus in C1 is n, so I have to write 6 over here. 6 times 2x to the power of 5, 6 minus 1 is 5, times 3y to the power of 1, plus 6c2, we do not know. So 6 factorial over 2 factorial and 6 minus 2 factorial. And 2x to the power of 4, 3y to the power of 2, plus, this was 62. Next it will be 63. 6 factorial over 3 factorial and 6 minus 3 factorial. 2x to the power of 3 and 3y to the power of 3. Plus 64. So it is 6 factorial over 4 factorial, 6 minus 4 factorial times 2x to the power of 2. See, the powers go on decreasing. 6, 5, 4, 3, now it is 2. And the powers of 3y will be going on increasing. It is 3, now it should be 4. Plus 65. Okay, 65, I know this to be equal to, this should be equal to 6. So I am not writing those things. And this is 2x to the power of 1, which is 2x. This is 3y to the power of 5 plus 3y to the power of 6. Okay. So this should be equal to 2 to the power of 6 is 64. 64x to the power of 6 plus, for this we will be needing the calculator. 2 to the power of 5 is 32. Yeah, you may say that if we are using the calculator, then we can get these also using the calculator. Okay, fine, no problem. I'm not using the calculator. So this is 2 to the power of 5 is 32, and 32, and this is 6 times 3 is 18. So it is 18. I'm assuming that you do not know the 18's table, so I'm doing in 2 steps. So it will be 8 times 2 is 6, and this is 256, and this will be 2 and 3, which is 6, 7, 5. Okay, so it is 576 x to the power of 5 and y. Let me just erase this. Okay, and then the next term, 6 factorial over 2 factorial and 6 minus 2 factorial, that is 4 factorial. So 6 factorial, I can write this as 6 times 5 times, it will be 4 times 3 times 3, 2 times 1, which is equal to 4 factorial. So why not we write it as 6 times 4 times, 6 times 5 times 4 factorial over 2 factorial times 4 factorial, so that we can cancel these two. And 2 to the power of 4 is 16. 3 to the power of 2 is 9. Okay, I'm putting the multiplication sign this way for this term. Okay, fine. 3 to the power of 2 is 9 y square plus this one is 6 minus 3 is 3 factorial, so we go up to 3. It is 6 times 5 times 4 times 3 factorial over, let me write the first 3 factorial expanded way, in an expanded way. So it is 3 times 2 times 1, and this one is 3 factorial. Okay. Okay. 2 to the power of 3 is 8. X to the power of 3. And 3 to the power of 3 is 27. Y cube. Okay, I think I will be needing the calculator, because I can do it manually, but it will be taking quite a lot of time. And I can cancel these two, and I can cancel these as well. Okay. So, okay, let me just continue over here, because I'll not be having sufficient space, or I can do one more thing. I can just shift it down. Okay. Yeah, that is the better option, I think. And then we come to this line. It is 6 factorial. And now you see there are 7 terms in total. So it will be 1, 2, 3, 4, 5, 6, and then 7. So which one will be the middle term? It should be the 4th term. 1, 2, 3. This is the 4th term. This is 6 we have got, and this is the numerical coefficient is 1, that is also known. Do we actually have to calculate this? No, we do not. Because whatever will be the value of this part, will be the value of this part. Okay. And we are seeing that it is 62. This is equal to 6 times 5, that is 30 over 2, which is 15. So 6C4 should also be equal to 15. If you are confused, if you really do not feel confident, let me show you. It is 6 times 6 minus 4 is 2 factorial. So, and this is 4 factorial. So I can write this as 6 times 5 times 4 factorial over 4 factorial times 2 factorial. And see, these two will be getting cancelled and you are having the same expression, 6 times 5 over 2 factorial, which is equal to 15. Okay, it has to be. So really we do not need to calculate this part again. 6C, what was it? It is 6C4. We really do not need to calculate 6C4. It is equal to 6C2. So we do not calculate this anymore. We simply write this as 15. 15 times 2 square is 4, so it is 4x squared times 3 to the power of 4. So 9 times 9 is 81. Y to the power of 4 plus 6 times 2 is 12. 12x and 81 times 3 is 243. 243y to the power of 5 plus 3 to the power of 6. 243 times 3 is 9 and 729. 729y to the power of 6. Okay. So actually it has become a little clumsy. Sorry for that. It is 64 x to the power of 6 plus 576 x to the power of 5y plus this one is 15 we have seen. Okay, and let us use the calculator just to save some time. It will be 15 times 16 times 9. Okay, so it is 15 times 16 times 9. Enter. 2160. 2160 x to the power of 4 y square plus this one is 5 times 4 is 20. 20 and then 20 times 8 is 160. 160 times 27. So 20 times 8 times 27. 20 times 8 times 27 is 4320. Of course, in a paper one, you will not be getting these huge numbers. They will be giving the power, manageable power, which can be found out manually. So the first one was a question which can be taken as a paper one question because the powers were really reasonable. So, but this one is you are having 7 terms and there are 2 and 3, the numbers over here in the terms also. So the coefficients are becoming really large. So this will be a paper 2 question, no doubt about that. Don't worry that you will be asked to multiply them manually. No one will be asking you. Okay. So this is x to the power of 3, y to the power of 3 plus 15 times 4 is 60, 60 times 81, 60 times 81, 4860. X square y to the power of 4 plus 243 times 12. 243 times 12. 2916. X y to the power of 5 plus 729 y to the power of 6. So this is the total expansion containing 7 terms. 1, 2, 3, 4, 5, 6, 7. And you see the powers of x, they are going on decreasing, and powers of y, they are just going on increasing. Okay. Now coming to the last question of this session. What is the third term in the expansion of 3 plus 6 to the power of, 3 plus x to the power of 6? Now, we have just seen that in case we expand the whole thing, we will be getting 7 terms, but we really do not need them. This is the third term. So, and what do you know? What did you notice? What is the speciality of the numerical coefficient? The upper number is obviously n, so it will be 6. The first term's R value is 0. It starts with 0, that we have seen. So the second term's R value will be 1, and the third term's R value will be 2. So do we really need to have all the 3 terms? No. If they are asking for the third term, we will just be giving them only the third term. Why should we be giving them something extra? They don't need that. If we want to give them something extra, we will be losing some more time. We will be wasting some time. So they have asked for the third term, therefore we will be giving them just the third term and nothing more. So first the coefficient part, n value is 6, so it is 6. What about the number, the lower number which represents the R value? For the first term R value, we have seen that it starts with 0. Then for the first term it is 0. For the second term it is 1. For the third term it has to be 2. So it is 6C2. And over here A is equal to 3. B is equal to x. N is equal to 6. So 3 to the power of, for the first term it should be 3 to the power of 6. For the second term it should be 3 to the power of 6 minus 1, that is 5. For the third term it should be 3 to the power of 6 minus 2, that is 4. Because 6, 5, 4, the powers are going on decreasing in steps of 1. So 3 to the power of 4, and x, the first term's power of x is 0. Second term's power of x is 1. The third term's power of x is 2. So this is the third term. Now we will be just finding the 6c2. Okay. So 6 factorial over 2 factorial and 6 minus 2 factorial, which is equal to, this is 4 factorial, so this can be written as 6 times 5 times 4 factorial, over 2 factorial over 4 factorial, times 4 factorial. So these two can get cancelled, and 6 times 2 factorial is 2. So 6 times 5 is 30 over 2 is 15. So this is equal to 15. Therefore, the third term is equal to 15 times 3 to the power of 4 is 81 times x square. And what is 15 times 81? 1215. Again, I am saying, since I have used the calculator for this multiplication, I could have got the 6c2 value also using the calculator. But my intention is to show how to find them manually. In case you are asked this, find the value of NCR as a question in the paper 1, you should be knowing how to find them manually, or else you will not be able to answer the question. Okay. So this is the third term, 1215 x square. Okay. So this is how you find the specific term from the binomial expansion. You don't have to find all the terms. In our coming session on next Saturday, we will be seeing, instead of third term, if it was, say, the fifth term, how to find them. Okay, and how to write the binomial expansion in a concise manner. How to, and what is the sigma notation? How to write it in a concise manner? Obviously using the sigma notation. And in case you are new, I think that you do not know anything of binomial theorem, and you have come to this class to learn what is binomial theorem. So you should know, it is quite obvious that you do not know the meaning of sigma notation. Fine. We will be learning the meaning, what is sigma notation, how is it used, and why is it used, and other things also in our coming session. Okay. So this is all for our today's session. Bye, and thank you for staying with me, watching this session. Bye.